Hello students, welcome to Mockiesgateacademy. So today's topic is electrostatics. I think we have in last class we have seen up to electrostatic force. So today we'll see charge density. Continuous charge density. So charge density is simple thing. So it is like density which we would have studied in a smaller class. So in case of general density is defined as mass per unit volume, right? So similarly, so or you can state it as in a certain area or in a given point how much of a quantities exist, right? So it is known as density. So in case of charge density, we split it as one dimension density, two dimension density, and three dimension density, right? So linear one is your one dimension density. Okay, it is denoted by lambda. So number of charges in a given linear distance. Okay, in case of area, number of charges in given area, number of charges in a given volume. In case of three dimensions, it is a simple concept, but it's these relations will be useful to simplify your electric field or electrostatic force formulas further. Okay, that is the importance of these formulas or these relationship. Okay, next one is electric field. So electric field is nothing but region around the charge in which its effect can be experienced, right? So in this case, you might have experienced it in using a magnets in your when you are young, right? So up to certain extents, there will be a certain influence, okay, which you can feel by yourself. So it is known as, so that's why it is electric field is also known as sphere of influence. Okay, sphere of influence. So it can be a sphere of influence of point charge or a system of charges. So whatever system you take, okay, up to which its effect can be felt, it's known as sphere of influence or electric field. Okay, next one is electric field intensity. Electric field intensity at a point is defined as the force experienced by a unit positive charge placed at that point. Okay, so there is an electric field E, it be an electric field E. Okay, we are placing in positive charge Q here. Okay, the amount of force, so we have studied the electrostatic force, right? Same concept. So the positive charge will experience certain force due to this electric field. Okay, so force experienced by unit positive charge is known as electric field intensity of that particular field. Okay, so next one is electric field intensity. So I already explained about it. Okay, force experienced per unit charge. So that's why it is F vector by Q naught, or a unit positive charge. Okay, so it can also be written as Kc into Q by R square, where Kc is the Coulomb's constant, Q is the test charge, and your R is the distance between the charges. Okay, next one is in a simple sense you can write F is equal to Q. Okay, so electric force in terms of electric field intensity can be written as F is equal to QE. Okay, so if charge is positive, force is directed towards the direction of the field. Okay, if you consider if the charge you taken is a positive one, the force is electrostatic force so developed will be towards the direction of the field. So in case of negative force, the force developed will be away from the or opposite to the direction of the field. So this variation can be plotted in the form of a graph. You will get an hyperbola. Okay, so these types of graphs, certain graphs are very important in case of your examination. Okay, this graph has electric field on its y-axis and distance between the charges on the on x-axis. Okay, next one, electric field due to system of charges. Okay, if it is similar to that of a force, right? So there will be a lot of I'm sorry, there will be a lot of electric if it is similar to that of an superposition principle, which is saw in electrostatic force, right? So we just simply summed up each charge's electrostatic force and a charge which we desire to study. Similarly, you have to add up each and every electric field intensities, so on a charge which we wish to study. So that is E is equal to E1, E2, E3 and so on up to E power n. Okay, so next one is electric field lines. Okay, electric field lines is nothing but pictorial representation. Okay, it is a pictorial mapping. Actually, it's a pictorial mapping. The line starts on positive charge. Always electric field line starts on positive charge and ends on the negative charge. Tangent on these lines. Okay, if you take any point on the line, you draw a tangent, it will give you any point on the line, you draw a tangent, it will give you a direction of the electric field. So the electric field lines due to positive and negative charges and their combination are shown below. Okay, next topic, next one is electric dipole. Okay, so electric dipole is nothing but 2 point charges. Okay, we are considering 2 point charges, a positive charge and a negative charge. Okay, so both are separated by a distance r or l, d. Okay, doesn't matter, it is separated by certain distance. Okay, so the line joining, okay, this line joining the two charges is known as dipole axis. It's a second term which you have to know to answer a theoretical type of questions. Okay, dipole axis. Next one is electric dipole moment. Okay, so since these are equal charges and which act in opposite directions, since they are separated, there will be a momentum that will be created, because since they are they are unlike charges, they tend to attract each other, they want to mingle, but the certain distance between, they are placed in such a way that they in a such equilibrium position that it doesn't happen. Okay, so that to create an electric dipole, right? So that moment between them will be given by P. Okay, which is nothing but charge into 2L, since the magnitude of these both charges should be the same. Okay, and their direction should be opposite, one should be a negative charge and one should be a positive charge. Okay, so their SI unit is coulomb per meter. Okay, next one is electric field due to an electric dipole. Okay, so in this case we are going to take two conditions, a point along the axial line, that is along the axis, right? So here we are considering a point P along the axis. So it after derivation of a simplification, we will get this one as a formula for axial line. Okay, electric field along the axial line. So when the distance distance is very much larger than the distance between the 2 point charges or the dipole length. Okay, so then the this equation is further simplified into 1 by 4 pi epsilon naught into 2p by r cube. In this case, what will happen is, since L is very small, we can consider it 0. So this will become r per 4 and r per 4, right? So on cancelling, it will become as r cube in the denominator. Okay, so in simple sense, in case of axial line, electric field is inversely proportional to the cube of distance between the dipole and the point charge taken. Okay, and you should also note the important point in this: direction of electric field any point on axial line is along the direction of electric dipole moment. Okay, it will be along the axis actually. Okay, that too from negative to positive. The direction will be from negative charge to positive charge. Next one is the equatorial line. So you use the same similar concept over there, and you can when L is very small, so on further simplification you will get an equation that you have to know this equation much better. Okay, so which you would be expected in our examinations. Okay, so the ratio between axial and equatorial points will be always be 2 times, it will be double the times. Okay, so electric field on the axial line will be always double the time that of electric field intensity on the equatorial point. Okay, so direction of electric field intensity on the equatorial line is parallel to the dipole. Okay, so this is the point, this is the equatorial point. So in case of axial, this it will be along the axis, we will be taking some area. Okay, and opposite to direction of the dipole moment. In case of axial, it will be along the direction of the dipole moment. Okay, okay, next we have to consider dipole in a uniform electric field. Okay, so we are placing an two equal and opposite forces acting on the dipole. Okay, right? So both are will be acting. So positive charge will be in one direction and negative charge will be in another direction. So since the magnitude is same, F due to positive charge will be in this direction, force due to negative charge will be in this direction. So what will happen is, if we place it in a uniform electric field, it will start rotating. So it will form a couple, right? Couple. So it will start rotating. So there will be a torque created. Okay, the torque can be calculated using the formula tau, which is equal to P into, it is it's not just a multiplication, it's a cross. Okay, so it's a vector notation. Okay, vector product, P cross E. Okay, P cross E. Okay, which on further simplification, P cross E is P E sin theta, right? P E sin theta. Okay, so when a dipole is placed, minimum torque will be produced when it is along the direction of the electric field. That is, when theta is 0 degree or pi degree, there will be very much minimum torque. That is, the torque will be nil actually. Okay, after a certain point, that the dipole will achieve an equilibrium position and it will not rotate further. The maximum torque will be obtained when the theta is 90 degree. Okay, both the formulas can be obtained from P sin theta. Okay, we're just replacing the angle value and we will get T minimum and T maximum. Okay, so what will happen if a dipole is placed in a non-uniform electric field? So in case of non-uniform electric field, okay, so for that we have to further finish a few points in a uniform electric field. Since in uniform electric field, after a certain position, the dipole will reach either stable equilibrium or an unstable equilibrium. Okay, what is the difference between stable and unstable equilibrium is, in case of stable equilibrium, that is at 0 degree, even the dipole moment will be along the direction of the electric. In case of unstable equilibrium, though the dipole will reach collinear path with the electric field, but its direction, dipole movement direction, will be opposite. Okay, so it will be unstable equilibrium. So simple difference is you can easily break the unstable equilibrium when compared to breaking the stable equilibrium. That is the difference. Hence, since I already know that minimum torque will be 0 in case of, so when the dipole achieves a stable equilibrium. So since the torque is 0, the net force is also 0. Okay, so this is in case of uniform electric field. So in case of non-uniform electric field, net force and torque can be calculated using the formulas which we studied earlier. Okay, next one is work done. So what will be the work done in rotating the electric dipole will be given using PE cos theta 1 minus cos theta 2. So theta 1 is nothing but we say what is the initial position. Okay, so then we are moving to say this is the electric field direction, this is the dipole, and it is in angle theta 1. So then it is moved to angle theta 2, right? So these values, so it will give work done to move even a degree. Okay, how much work will be done. So step by step you can study the electric dipole movements even when it's rotating. Okay, then we have to similarly using the same formula you can calculate the potential energy of the system also. So since work done is nothing but equal to energy, so you can apply the same formula for potential energy too. Okay, so here I have solved you for 90 degree, from 90 degree, that is when it is perpendicular to, I want to bring it to a stable equilibrium, how much energy it will be. So though whatever energy I spend will be, or whatever work I done will be stored by the dipole as a potential energy. So only we are stating it as a potential energy here. Okay, similarly from stable equilibrium to unstable equilibrium, what must be the work done. Then stable equilibrium to the position. Okay, so maximum torque position, what the work must be done. Everything is given. Just go through it. Okay, just memorize it basically. Okay, just don't memorize plainly, understand the concept and try to memorize it. Okay. Okay, students, I think today it's enough. We'll see the next topic in next class. Okay, so for further updates visit our website, and please don't forget to subscribe our YouTube channel, so and press the bell icon. Thank you.